Form of problem number one is fairly straightforward. It's a calculus problem to show that the average value of a pure sine wave is equal to 0. I will let that go for now and go on to problem number two. In problem number two, we're given a triangle waveform that has rectified, so the bottom portion has been chopped off. With this rectified, half-wave rectified waveform, we want to find the average and the RMS. Well, first of all, to find the average, we know that the period of this waveform is equal to t seconds. However, over one period, the total area that we have under the voltage waveform is equal to, we have two triangles. Let's take each triangle separately. This triangle has an area of a half the base times the height, which is 1/2. The base is t over 4, that's this distance, and the height is 10 volts. But there are two of them. There are two triangles, so that the total area is equal to t over 4 times 10. Therefore, the average value would be the total area divided by the period. And so I take the total area of 2.5 times t, what this is, 2.5 times t, and divided by t, give me 2.5 volts for an answer. 2.5 volts would be the average value after rectification. In part B, we have to find the RMS value. So what I need to do is to take the waveform I have and to square it. Every point in here is moved up by a factor of squaring, and so I'll end up with what look like two parabolic arches. So I need to write the equation of this line. The equation is a discontinuity here, right, and the equation over here. So for instance, between 0 and t over 4, this section in here, the voltage is described, call it V sub 1. The voltage is described by m times c plus some intercept. The slope, in this case, it's a negative slope, and the slope goes down from 10 down to 0, while this is going from 0 to t over 4. So we actually have 10, the vertical change, divided by the horizontal change, which is t over 4, which gives you 40 over t, or times little t, plus the intercept is 10. So I'm ending up now with 40 over t times t plus 10 as the equation that describes what's going on between this point and this point. One question, the slope is negative, so I put a minus sign in here. It's minus 40 over big T times T plus 10. Now, when I go into the next range between minus T over 4 and 0, in this range over here, this straight line is described as follows. V2 is some slope plus some intercept. The slope in this case is equal to 10 divided by t over 4, this is times little t, plus the intercept in this case is 10, same point of intercept here. So this comes 40 over big T times t plus 10. So I have two different equations. Now I need to square each of these. So I will square this one, minus 40 over t plus 10, square that. Meanwhile, I have discontinuity, squaring the other part over here, 40t over t plus 10, square that. Now this becomes a little bit more involved. I start squaring it, and then once I've squared it, I find the area by integrating this part over here from 0 to t over 4. Integrate this part from minus t over 4 to 0. Take the two areas, two integrals, combine them into one, get a total area. Then once I have the total area, and becomes very much of a calculus problem here. I take that total area and divide it by the period t to get the mean value. So remember how I squared them first, find the area, find the mean of square, and then take the square root of that result. After a fair amount of algebra and so forth, the answer comes down to 4.08 volts. And I think you can get a very good handle on this problem once I've shown you this much. I went through the solution that's in the solution manual.